Good morning, friends. Today we are going to see the next point from the topic superposition of waves, that is the practical determination of end correction. Already in the last lecture we have seen what is the meaning of the end correction. Now here we are going to derive the equation for end correction. Friends, here we are going to see two equations for pipe open at one end and for pipe open at both ends. So I am going to see the equation for end correction for pipe open at one end. Friends, open at one end, it means closed at one end. Both have the same meaning. So just I am going to draw the diagram so you can get the idea. So here pipe is closed at one end. Closed at one end means open at one end. Both have the same meaning. When the air will pass through it, then the formation of node and antinode will take place, and the distance between the node and antinode is denoted with the symbol L. So length L is equals to lambda upon 4. Friends, in your textbook the equations are written directly. So here first I am going to explain how does that equation comes based on the diagram, and then we will write the equation. So here you will get a clear idea regarding with the equation. Now here length L is equals to lambda upon 4. Lambda is equals to 4L. But what is the formula for velocity? V is equals to L into lambda. So V is equals to L. What is lambda? 4L. So V is equals to 4L. So this is the basic equation for the pipe open at one end. Here we have the equation for velocity. So velocity for pipe open at one end, V is equals to 4L. Now remember, capital L is equals to small l plus e. Okay. Now here we have got the equation for the velocity. Now our aim is to determine the equation for the end correction. So we have to compare the two velocities. V1 is equals to 4. We can write here L1 plus e for first wave, or V2 is equals to velocity 4 n2 plus e. So this is first velocity, this is the second velocity. Now we have to compare these two. V1 is equals to V2. So 4 n1 plus e, 4 n2 in bracket n2 plus e. So 4 will be get cancelled, the n1 into bracket n1 plus e, n2 in bracket n2 plus e. Now do the multiplication, n1 n1 e, n2 e. Now take these like terms, n1 e minus n2 e is equals to n2 minus n1. So take e as a common. So n1 minus n2 is equals to here n2 minus n1. So divide with these terms. So you will get e is equals to n2 minus n1 upon n1 minus n2. So this is the formula for the end correction if the pipe is open at one end. So friends, this is the equation. Again I am going to explain this part. So here equation for end correction for pipe open at one end. First we have drawn the diagram. So in your diagram you will observe that one node and antinode is formed, and the length or the distance between the node and the successive antinode is lambda by 4. So length of the vibrating air column is L is equals to lambda upon 4. So lambda is equals to 4L, but velocity V is equals to N lambda. So V is equals to 4L. So this is the equation for the velocity. Now we are interested for the end correction. So we can consider the two wavelengths having the first length L1 having the velocity L2, and let us consider the second air column having the length L2 and the velocity V2. So here based on this equation we can write V1 is equals to 4 L1 plus E, V2 is equals to 4 N2 into bracket N2 plus E. Remember L1 and N2 these are the frequencies, L1 and L2 are the length. So in your textbook this equation started from directly here. So how does this 4 and N comes? I have explained here. Now both the velocities, because the velocity of air will always remain the same. So V1 is equals to V2. Then rearrange the terms. So 4 N1 into bracket N1 plus E is equals to 4 N2 into bracket N2 plus E. Now if we observe, then from both the sides 4 will be cancelled. So N1 into bracket N1 plus E is equals to N2 into bracket N2 plus E. Now N1 plus N1E is equals to N2 plus N2E. Take out the E as a common, and if you will divide, you will get the final equation as E is equals to N2 minus N1 upon N1 minus N2. So this is the equation for end correction if the pipe is open at one end. Now friends, we are going to see the second equation, that is if the pipe is open at in the place of one, I am writing both. If the pipe is open at both ends. So we are going to see the equation for pipe is open at both ends. So I have to do the changes in the diagram. Now as the pipe is open at both ends, so the diagram will be just like this. So you will observe that node will be here, and the length of vibrating air column, the distance between the two antinodes is a lambda by 2. Right? So the equation will becomes here length L is equals to, in the place of 4 we can write 2. Length L is equals to lambda by 2. Lambda is equals to 2L, but V is equals to N lambda. So V is equals to, here we can write the 2NL. In the place of 4 it will be equals to 2NL. So this is the equation for velocity. Now friends, as the end correction is at the both the side, then while writing the equation V1 is equals to, in the place of 4 I can write the 2. At the same time, as the end correction is at both the end, so we have to add this E plus this E. So end correction is twice E. In the place of E, we have written it as a 2E. So end correction will be the 2E. But V1 is equals to V2. So again we can write here 2. In the place of 4, you have to write the 2. And in the place of E, what you have write? 2E. In the place of E, what you have write? Twice of E. 2E we have written. So in the next step, 2 will be get cancelled there. So in the place of E, what you have write? In the place of E, you have written 2E. So here the terms 2E will come. Here also the term 2E will come. Now we have to do the multiplication. So N1 plus here and here we can enter twice N1E, here twice N2E. Now here is the term, so N1, now here we can take as a, take the terms twice N1E minus twice N2E is equals to N2 minus N1. Now take 2E as a common, so if we take 2E as a common and if we are dividing, so finally we are getting the equation as E is equals to N2 minus N1 upon 2 into the bracket N1 minus N2. Friends, again I am going to explain this equation. Here you will observe that the equation, we are going to derive the equation for end correction for pipe open at both ends. You will observe the pipe is open at both ends. So when the pipe is open at both ends, then the antinode is found at the both the end. Now we can write that the length of the vibrating air column L is equals to lambda by 2. So length L is equals to lambda by 2. So lambda is equals to 2L, but V is equals to N lambda. So V is equals to 2NL. That is the basic equation. Then for the two frequencies, the two different lengths are there. The velocity will be V1 and V2. So we can consider as a V1 is equals to twice N1 plus 2E, because why we are using the 2E in connection to both the end. V2 is equals to 2 into bracket N2 into the bracket N2 plus 2E. Now both the velocities are the same, so we have to compare V1 is equals to V2. So compare these two will be get cancelled. Again do the multiplication. So N1 plus twice N1E, N2 plus twice N2E. Take out the 2E as a common, and then we are getting E is equals to N2 minus N1 upon 2 into the bracket N1 minus N2. So friends, we have studied the equation for the end connection. We have considered both the cases if the pipe is open at one end and if pipe is open at both ends. Once you have got the once you understood the first equation, in the similar manner you can write the second equation. So I hope you have understood this part. Make the note properly and try to solve this equation. Thank you. Have a nice day.